of physics.
Of ballet!
There was a friend to me in a bed of love.
Ballet dancers are constantly embodying the principles of mechanical physics. Whether they are balancing, turning, or jumping, their movements are dictated by the surrounding and applied forces. Because of this, ballet is a perfect example of how physics applies to the real world.
Many positions in ballet demonstrate motionless poses over a small surface area for support. Balancing relies on the center of gravity as it passes vertically through the body to the supporting area on the floor. In order for a dancer to achieve a perfect balance, there must be no net force on the body. The force of gravity downwards and the normal force of the floor upwards cancel each other out, creating a sustained balance. This demonstrates Newton's third law of motion, which states, for every action there is an equal and opposite reaction. The forces of two bodies against one another are equal and directed in opposite directions. A dancer's center of gravity is easily out of equilibrium, so it doesn't remain over the supporting area, causing them to fall over. Gravity acts vertically on the body. To jump and lift your body off the ground, you have to apply a force greater than that of your body weight. The direction of the force applied to jump is down. The height of the jump is based on the downward vertical distance where the force is exerted. This means that a dancer will reach higher if they come from lower, which is why almost all jumps in ballet come from a position where the knees are bent.
A ballerina needs a large amount of momentum in order to jump high. Momentum is dependent on the mass of the dancer. The greater the mass of the dancer, the harder it is to stop moving at a high speed, going from a jump into another step. This is because the ballerina has a large momentum. It will take her a longer time to stop moving.
Projectile motion is used in the grand jeté, which is a horizontal jump. The initial velocity of the dancer decreases as she goes higher, until it is zero at her maximum height. The dancer accelerates downward as she goes back towards the floor. Dancers use marley floors because they are bouncier than wood or cement. This material decreases the force on their knees and ankles when they jump. This happens because the flexibility of the floor allows an increase in stopping time, which decreases the dancer's momentum as well as the force on their bodies.
Dancers use a substance called rosin to create friction between their ballet shoes and the floor on which they are dancing. Since they move around so much, there is not much potential for friction for dancers, so they have to maximize friction by dancing on marley floors. This surface must be able to provide horizontal forces for dancers to be able to rotate, slide, accelerate, and jump off of the surface. Flat ballet shoes typically have a leather sole, which creates a lot of friction. Also, when the dancer is on releve, their toes take up more surface area. However, pointe shoes are covered with a satiny fabric, which does not cause as much friction as leather. The box of a pointe shoe also takes up less space than a flat shoe. All of these things make it easier for a dancer to turn on pointe than on flat.
Angular velocity is how fast an object spins. Rotational inertia is the tendency for an object to keep rotating. The amount of rotational inertia will determine how difficult it is to start an object spinning. In this case, the object would be the dancer. In order to rotate faster, she has to decrease her rotational inertia. This can be done by decreasing the mass and making sure that the object is close to its rotation axis. This is why dancers spend a lot of time exercising and warming up. Having a slimmer body will help the technique.
In fifth position, the dancer's feet are placed heel to toe, creating a small distance between the feet. Because of this, a larger amount of force is required to do a pirouette. However, in fourth position, the feet are placed apart, so less force is required to do the same turn.
Your lips are on my skin, losing focus. Caffeine is setting in. We're on something, but nobody else can tell.